Hi, in this video we are going to talk about map container. A map is similar to a set in a way that it is also built using red black tree. So both set and map, they use red black tree internally. The difference between set and map is set is used to store only keys. Map on the other hand is used to store key value pairs. So every item of a set is a single object. Every item of a map is a pair. Let's take a look at this example. Before we go to example, one more thing, like set elements in the map are ordered. And this time we have two things, key and value, but items are ordered according to keys. By default, they are ordered in increasing order. You can change the order by providing your own comparison function. Let's take a look at simple map. We have a map where key is integer, value is also integer. These two can be any data type. You can have a string integer map where string is key and integer is value. Similarly, you can have a string or any other user defined data type as well. So we create an empty map. Now we insert the value 10 as key and 200 as a value. So we insert pairs in the map. This is another way of inserting key value pair in the map. I'll soon discuss the difference between this and this. I'll cover the difference. There are some interesting facts about these two things. Then we insert the third key, 3 as the key and value as 300. After that, we traverse the map. So what will be the output? What is the smallest key here? 3. So you will get 3 as first thing in the output. And we get the key using first and we get the value using second. So we'll get 3 and then 300. After that, the next key 5. So we'll get 5 and 100. After that, next key 10. So we'll get 10 and 200. So that's the output. There's a space here. That's the output we get of this program. Let us quickly talk about one more interesting fact. If a key is already there and if I call one more insert between these two, say I call m.insert 3 and 400, or maybe any other key which is present like 5 or 400, because 5 is also present, or 10 or 400. Basically the point is, if there is a key already present in the map and if I'm calling insert on the same key with a different value, then this new key value pair is completely ignored. The behavior is same as set, right? Set we discussed. So what will be the output of this program? If I add this line after this, the output is going to be same. We'll get 300, 500 and 200. Let us take a look at this program. This is an interesting program to show the difference between insert and this square operator. When you just insert an element here, you have only one item in the map, right? So the size is going to be 1. We have only inserted one item. Now when we come here, we have accessed an item which is not present in the map using a square bracket. So what happens in maps, if you access an item using these square brackets and if the item is not present, this item is inserted into the map. So now 20 is inserted into the map. So this is only key. What will be the value? Value will be some default value. If it is an integer, the value is going to be 0, right? So now your map has two things, 10, 200 and the other thing is 20, 0. That's the value inserted because you accessed an item which is not present. So this square bracket inserts that item. What will be the size now? Size will be 2. So that's the difference between square bracket and insert. The square bracket is going to insert an item even if you just access using a square bracket. We can use a square bracket to update the values also. Like we can do something like m10 equal to 300. What will be the output now? The size will remain 1. It will go to that key, it will return you the reference of the value for this key and it will update using the reference, right? So this value is updated from 200 to 300, and the output now is going to be 1 1. The first size is 1 and the second size is also 1. There is one more operator which is called at operator. At is different from, so let's talk about the at operator. At operator can be used in place of this. So we can also do m dot at 10 equal to 300. What at operator does, it kind of works same as your square brackets. It accesses an item at the given key, but here is a difference. If the key is not present, then what was your square bracket doing? It was simply inserting the key with a default value. What this at does, it throws out of range exception. So if you try to access any key which is not present in the map, you will get out of range exception. This at was added later in C++ standard to have better coding, right? Because what was the square bracket was doing, it was simply adding the key if it was not present. But at ensures that it accesses or gives the reference of the value only when this key is present. So the output of this program is going to be same. The effect here is going to be same. If you write m10 equal to 300, that's same as this. They both have the same effect. Here this will print 1 and this will print 2. But if you change it to 20, then this will throw an exception. And what this will do, this will actually create a new key, right? So at function works only when key is already present. This square bracket creates a key, and that function throws an exception if the key is not present. Let us quickly talk about begin and clear functions. So they are same as any other container. Begin gives you address of the first element and gives you address of the last element. They can be useful, particularly when you want to find the smallest element. You can just call the begin because map is sorted, right? Smallest key value pair, right? Where the key is smallest. And can be used to find the largest. Please remember, and points to the element beyond the largest. So if you want to find the largest, you will have to do iterator minus minus after assigning m.n to the iterator. There are more functions like rbegin, rend, which gives you reverse iterators. So if you want to traverse in the reverse direction, you can begin with rbegin and go to rend by doing iterator plus plus. There are constant iterators, cbegin, cend, crbegin and crend. So they are same as other containers. They work same as other containers. I have used auto here, but we can use that complex syntax map int colon iterator to get the iterator. To avoid all the typing, it's good that we use auto, right? So that we do not have to type this long data type name. So we've talked about all these functions: at, insert, operator, size, empty, clear, begin and end. We'll now talk about more functions on map. Let us now talk about find function on map. Find function takes a key value. It finds if the given key is present in the map or not. If the given key is present, then it returns iterator having address of that record. Otherwise, it returns m.end. Please remember, and is a special marker which does not point to any valid value. So in this program, I have created a map where the key is integer and value is a string. Then I have inserted 3 items. Key is 5, value is GFG, key is 2, value is ID, key is 1 and value is practice. Please remember, we can call find only on the key. We cannot call find on a value, right? So it searches the given key 5 in the map and this key is present. So it will not return m.end. It will return iterator to this key, this record, and you will get the output as found in this program. Let's modify this program and say we have 3 here. Can you guess the output now? You will get not found because 3 is not present in this map. Let's modify the program slightly more. Let's see the more understanding of this find function. Say I write a loop which begins from find of 2 and runs till iterator is not equal to m.end. Then I do iterator plus plus. And then I print cout. So please remember, when we iterate through an element in map, we get a pair, right? This iterator points to a pair. And we print the first element of the pair using star it.first. This iterator is actually having address, so we need to dereference it. And then we print star iterator second. And let's put a new line after it, \n. So what is the output of this program? We find 2 here, 2 is found, so we get the iterator pointing to this element. Now we begin from this and traverse in the map. So map always has values in sorted order. So you begin from a value, and if you have stored in increasing order, then it will print all the values which are greater than or equal to 2. So what it will print? It will print 2 and the IDE. We're printing first and then we're printing second. Then there is a new line and then it will print 5 and GFG. So that's the output of this program that we've written. So find function is used to find an element. It returns iterator to the element if it is present. It returns m.end if not present. Let us now talk about count function. So count function is also used to find if an element is present or not. In find function, we get the address. In count function, we either get 1 or we get 0. Please note that map and set, they do not allow multiple keys. So count will return either 1 or 0. Although the return type of count function is size type, size underscore t type, but it returns either 1 or 0. So if we call count for 2, what do we get? We get 1. So we get the output as found, right? We print not found when we get count 0. So the output of this program is found. And if I change this program and if I put say something like 3 here, then the output is going to be not found because count for 3 is 0 in the map. Let us now talk about lower bound function. Lower bound function takes a key. If the key is present, then it returns iterator to that object or pair. If the key is not present, then it returns iterator to the key which is just greater than the given key, right? And if the key is greater than the greatest, then it returns m.end. So m.end is always used something which does not point to anything, and when you don't find anything, it's used in find, it's used in lower bound, used in upper bound. Let's see what happens. We have 3 records here, 1, and they are in sorted order because it's a map. 1 practice, 2 IDE, and 5 GFG. So we have 3 records in this. When we do m.lower bound 2, we get iterator to this record, this pair. This is a pair, right? So what happens now? We get the output as 2, right? And if I print dot second, I will get IDE. So the output of this program is going to be 2. Now let's change it. Let's change this program and let's say we change it to 1. What do we get now? We'll get 1 here. Now let's change it further. Let's change it to 3. What we will get now? We'll get the just greater value because 3 is not present in the map. So what do we get? We get 5. Let's change it further. Let's say we put 7 here. What do we get now? We get no equal or greater value. That's the output we get, or greater value. So lower bound finds a value if it is present. If not present, then just greater value. And if it is greater than the greatest, then m dot n. Let us now talk about upper bound function. Upper bound function returns the greater value, just greater value. If a value itself is present, then it does not return that value. It returns the value which is just greater than that, just ahead of it in the map, just next value in the map, because map is sorted. So please remember, greater, smaller, they have meaning only when your keys are in increasing order. If the keys are in decreasing order or in some other order, then you can say upper bound function returns the next key, right? And lower bound function returns the same key if it is present or the next key. So that's the meaning of lower bound and upper bound. So let's see what does it return here. So we are searching for 2 and keys are here in increasing order, right? If I change greater, then that order will change, right? It will decreasing order and the output will be different. Here we have keys in increasing order and the output here is going to be 5. The just greater value than 2 is 5. Let's change this program further. Let's say we have the value 1. What will be the output now? The output will now be 2. Let's change it again. Let's put something like 7. What will be the output now? 7 is greater than the greatest. So the output will be no greater value. Let us play around a bit. Let us put greater function here. Greater int, because keys are integers. So what will happen in this map now? You will have keys stored in decreasing order value. This is first, this is second, this is third. Now, if you call upper bound on something, say 2, what will you get? You will get the next key. And what is the next key? Next key is 1, because we have decreasing order now. So the output of this program is going to be 1. If you put something like 7, you will get 5, because keys are stored in decreasing order. But if you put something like 0, you will get end, because they are in decreasing order. That's how they are compared in the upper bound function. Let us now talk about erase function. Erase function is used to remove a key value pair or a set of key value pairs. Let's first talk about very simple syntax where we pass a key and this erase function deletes that key, right? So we pass 5 to it. What it will do, it will remove this key from the set and the output of this program will be 3 first, because there are 3 keys, then 5 is removed, so then the output will be 2, because this key is 5. This key 5 is removed from the set, from the map. Now let's talk about a variation of erase function. The erase function can also receive an iterator as a parameter. So we can call m.find 5. So m.5 will return an iterator and we pass this iterator to this erase function. This behavior is going to be same as the previous call. We'll get the same output. We can pass either a key or we can pass an iterator to the erase function. There is a third variation of the erase function where we can pass begin iterator and end iterator. So what will happen now if I pass m.find 5, let's say I pass m.find 2 and then I pass m.end. Now what this erase function will do, it will take the iterator to 2, then it will consider this as a begin iterator. So the first parameter is begin iterator and the second parameter is end iterator. So it will begin from the begin iterator. It will remove all the elements one by one until it reaches the end iterator. It does not remove the item at the end. That is why we passed end, which is beyond the last. And it removes every item from this iterator to an iterator just before it, right? So what it will remove? It will remove, so your map contains 1, 2 and 5 in this order. GFG, and 2 is IDE and 1 is practice and 5 is GFG. So it will you're passing an iterator this as a begin iterator. You're passing an iterator just after 5, the end iterator here points, right? So it will delete this, and then it will stop at the end. So your map is going to contain only one element after this call, and the output is going to be 3 and then 1. Let us now talk about internal working and time complexities of different operations in a map. Map, like a set, is a red black tree, right? So in set you had only keys, in map you have key value pairs. So among the key value pairs, your keys are used to order the items in your red black tree. And most of these functions that we have talked about, they work on key, like find works on key, count works on key, erase works on key. So the time complexities, they are all going to be same as set. They are all same as set. In fact, you can refer the set time complexities and you will find we are talking about the same time complexities. Let's quickly cover. So begin, end, begin, end, size, empty, they are all big O of 1 because size is maintained as a member variable in the map class. So they are all big O of 1. Empty has to just check whether the size is 0 or not. Begin and end are also maintained, so they just can be found in big O of 1 time. Begin and end are also big O of 1, they are just reverse pointers. There are more variables, more variations like CR begin, which is constant reverse pointer to the begin, CR end, C begin and C end. These are all big O of 1. They are all big O of 1 in map. Let's now talk about these. Since we use a red black tree, we can find a key in login time. We can count and find are almost similar because that also finds, it returns an iterator, this returns count. So they both are login. Erasing a key is also login. If you're given a key and you want to erase it, it's login. Insert is also login because we just want to insert into red black tree, which is login. This operator is also login because it works sometimes as an insert, sometimes as a find. So if the key that you pass to the square bracket, so I'm talking about this operator map 10 equal to 20 that we wrote earlier. So if you try to access M10, if it is not present, then this operator actually inserts into the map, right? So then it works as an insert, otherwise it works as a find. So it finds and updates the new value. So there's one more actually right, that does index out of bound checking. This is also login. This does not do index out of bound checking. This does index out of bound checking. Range out of bound checking, not index rather. I mean, if something is passed which is not in the map, it will throw an exception. But this will not throw an exception. It will simply insert that item. So these are the time complexities. They are login. There is one special interesting case. If you are calling find and if you are given iterator to the record, then find on average takes big O of 1. It's like if you're given pointer to a node in a red black tree, and if you're deleting multiple nodes, then you can delete them in big O of 1 average time. Big O of 1. Right, so that's the special thing about erase function. This is erase I'm talking about. So erase takes big O of 1 time on average if you're doing multiple deletions by passing the addresses. Let us now talk about applications of map. So map has everything same as set. It's time complexities, its applications. The only difference is set is only key, but when you have key value pairs, you use a map. So as we discussed in the set applications are when you have a sorted stream of data and you want to store this data in a container, you use set or map. If your data is only key, then you use set. If it is a key value pair, then you use a map. Other application is as doubly ended priority queue. If you use a normal priority queue or a heap, it can only find maximum or minimum. It can only allow operations like extract minimum or extract maximum. But with a map, which is in a red black tree, you can find maximum, find minimum in big O of 1 time. Because minimum is always at the begin if you are storing increasing order, and maximum is always at end -1, right? So that's how you can find max and min. You can do extract maximum. You just have to remove the last element, which is log n. You can do extract minimum also. You just have to remove the first element, which is log n again. Removing an item erased with the given iterator is, in fact, pick of 1 on average. So it can work as a priority queue. The difference between set and map is again the same. If it is only key, then you use a set for doubly ended priority queue. If it is a key value pair, then you use a map.